All right, here we go. Solve the triangle with angle B being 36 degrees, side A being 10 units, and side B being 8 units. Now solving the triangle means to, in case you forget, means to find all three angles and all three sides. And so this is going to be actually a pretty interesting problem. I made a triangle here fitting those specifications, so B again being 36 degrees, its opposite side, so side B being 8 units, and then side A being opposite angle A being 10 units. And those specifications are fixed on this triangle. And notice here's one possible option with uh, approximately 96 degrees for angle C, meaning that side C is approximately 13.5, um, and then angle A would be whatever 36, let's see, what did that, 36 plus 96, um, it'd be right around 47 degrees. Something around 47 degrees right there. Now, the issue is that that's not the only possible triangle with these specifications. If we were to take point A over here and move it all the way down, notice that we still have those same specifications being met, that B is 36 degrees, angle B, that side B is still 8 units and side A is still 10 units. However, side C, and angle A are all going to be quite a bit different. And so let's look into why that is, how that can be, so on and so forth, because again, I think it ends up being pretty interesting here. So let's take a look. Let's how do we want to go? Let's go with this triangle first, because I think that's the one you'll come across naturally. Because A here is going to be acute, and you'll see why that's important in just a moment. So if we have our ratio we're going to set up is sine of, we're going to do sine of B, that should be a capital, sine of B over side B is equal to sine of A over side A. And hopefully you noticed from last video that whatever your unknown is, it's typically easier to have that up in the numerator. There's just less work to do. And since we're going to find angle A first, because we're given side A. So let's set that up. Sine of B, that's going to be sine of 36 degrees divided by side B, which is 8, equals sine of A over side A, which is 10. Multiply both sides by 10, and we're going to get that the sine A, so we want to find angle A, so we're going to do the inverse sine, or actually let's set this up slightly differently. We won't skip those steps. Multiply both sides by 10, and we get sine of A equals 10 times sine of 36 degrees over 8. Take the inverse sine, and so we're going to end up with A is equal to the inverse sine of all that stuff there. So 10 times the sine of 36 degrees over 8. And let's hit that into our calculator. From our graphic earlier, we know that it should be right around 47, but let's actually work that out. So inverse sine of 10 times the sine of 36 degrees, and that divided by 8. And yeah, 47, let's say 0.3 degrees. So A equals 47.3 degrees, which would be this one right up here, 47.3 degrees. Now, once we know that, now we can set up, now we can just subtract, well, 36, and this one we wouldn't know quite yet, so let's go back to the problem itself. So we'll have, hey, our triangle looking something like that there, that if this is 36 degrees, and this one here is now, we're finding out 47.3 degrees. Then this one here needs to be 180 minus 47.3, and then that minus 36 degrees. So it is 180 minus 47 plus 36, 180 minus 36 plus 47.3, and we get 96.7. So 96.7 degrees. That means that, so there we are. Angle C. Sorry, I should have an angle symbol there probably, just to be clear about A. So angle C is equal to 180 minus 36 degrees plus 47.3 degrees, meaning that angle C is equal to, we said 96.7. 96.7 degrees. All right, and now to find side C, so if that's angle C and we want to find side C, we've got to set up our ratio using, and you got a number of options here. Actually, I'm not going to run through any of those. I'll let you sort that out from there. So if you pause the video, make sure you're actually able to do it, and you get that C, side C, is something right around, again, please pause and check your work first, right around 13.5. And if you're getting right in that vicinity, try not to drop too many decimals. That might be a reason you're slightly off, but should be getting something right around 13.5 units. All right, and so that's all fine and good. And however, as you recall from the beginning of the video, we said this isn't the only possible triangle. Okay, this is not the only possible triangle. We also need to consider this triangle over here. And so how in the world would we be able to find that? Because we found angle A and said, hey, angle A was 47.3 degrees, and hey, this is not 47.3 degrees. How would we find that? And well, we need to think back to the inverse of sine. What does the inverse of sine mean? And so let's sketch this out. If we said that the inverse of sine, and I'm going to calculate this value right here real quick, and just get a rough estimate of it. So what is 10 times the sine of 36 degrees? What is all that divided by 8? It's right around 0.734. Okay, so 0.73, we'll round up to 5. This is right around 0.735, yeah. 0.735. All right, well, let's think of sine, and specifically the inverse of sine. So if I'm saying that there's a triangle right here with an angle, some angle, but the sine value is going to be 0.735, and we found out it would be 47.3 degrees. And remember, this is our domain of the inverse of sine is only in quadrants 1 and 4. Only 1 and 4. However, we could have a triangle over in quadrant 2 that has that exact same sine value. So 0.735. We could have the exact same sine value. It would have the same reference angle, 47.3 degrees. We just would need to reason through and figure out, well, what is that angle right there? What's that angle going to be? And so how would we find it? Well, 180 degrees minus that reference angle. So 180 degrees minus 47.3 degrees gives us, what is that? 132.7? 132.7 degrees. That would be the other possibility for angle A. The first one we found was when A was acute. Now we're finding when A is obtuse. Acute being less than 90 degrees and obtuse being more than 90 degrees. So now we've here, let's measure that angle. Oops, wrong side. There we go, 132.3. So let's bring it down. 132.7 is where we should be. Obviously, I'm a little bit off with my measuring tools, but something right around there. And again, that obtuse one, we would not be able to find that obtuse angle just using the inverse of sine. And so we need to realize what's going on and be able to evaluate with that in mind. So that all being said, now let's resketch that triangle. Something like that, with now angle A being 132.7 degrees. This one being fixed at 36 degrees. In that case, what is C going to be? What is C? Well, it's 180. Angle C is equal to 180 degrees minus 36 degrees plus 132.7 degrees. That gives us angle C should be right around 11.3 degrees. From there, keep on going through, and you should get that side C. Again, pause, try it on your own, set up that ratio either with sine with B or with A, whichever one you prefer using there. But you should get right around 2.7 units. All right, and now we've got two different triangles that we've solved, so we actually should have 6 pieces of the first triangle and then 6 pieces of the second triangle. But hope that makes sense and hope that helps. All right.